In section 6.4, we're dealing with graphs of logarithmic functions. So in example number 1, we want to be able to identify the domain of a logarithmic shift. So given a logarithmic function, we want to be able to identify the domain. Number 1, you're going to set up an inequality showing the argument greater than 0. Number 2, you're going to solve for x, and then you're going to write the domain in interval notation. So for example number 1, we're trying to find what is the domain of f of x, which is equal to the log of base 2 of x plus 3. So what we want to do is we want to look what's inside this logarithm. So before we go ahead and figure out as to how and why we have to set this to be greater than 0, let's just take a look at the calculator. Okay, so if I put in the logarithm of, let's say, 1, okay, that gives me an answer of 0. If I put in the logarithm of 2, well, it's getting bigger now. It's going up to 0.301. If I put in the log of 3, then we're getting 0.477. If I put in the log of, let's say, 89, okay, it's getting higher and higher and higher. Now, let's say if I put in the log of -1, well, we're getting an error because it's a non-real answer. So if we put in the log of -9, again, we're getting a non-real answer because it does not accept negative numbers. So in this scenario, what we want to be able to do, and let's go ahead and try the log of 0. That also gives us an error domain. So we cannot include 0 in the domain, which is the reason why you only have greater than and not greater than or equal to 0. So the logarithmic function is defined only when the input is positive. So this function is defined when x plus 3 is greater than 0. So if we solve the inequality, we're going to subtract 3 to both sides. X is greater than -3. So that means our interval notation would start at -3 and go all the way to positive infinity. But because it's just greater than, we have a parenthesis here and of course a parenthesis after the infinity.